Hello and welcome everyone. Hope you are liking my videos of data science. I have discussed many topics of data science till this video, and basically these are the important topics, the most important topics of data science that you must know if you are going through data science. Now today's topic is very important, which is dimension reduction. So basically, we all know what is dimension. Dimensions are everywhere. Dimensions are around us. So it is different in data science. Basically the concept is from the real world, but it is a little bit of different from the real world. Dimension reduction is a crucial technique for simplifying data and improving model performance. By identifying and removing redundant or correlated variables, we can achieve greater insights, reduce computation complexity, and enhance model accuracy. Basically, to improve the performance of our model, basically, listen carefully what I'm saying, that to improve the overall performance of our model, we need to apply dimension reduction. It removes the redundant correlated variables, means the variable that are repeating again and again. It removes all them. It achieves greater insights. It will also reduce the complexity in our data, and it also enhances the accuracy of the data. So basically dimension reduction is very important in making our model more accurate, more boosted for performance, and more efficient. Introduction to multicollinearity. So what is multicollinearity? Multicollinearity occurs when independent variable in a regression model are highly correlated, making it difficult to isolate the individual effect of each. Basically, if they are highly correlated with each other, then it is very difficult to separate them, isolate them, so the individual effect will be low. Consequences: it can lead to unstable and unreliable regression of coefficients, making it challenging to interpret the results. Identification: several methods can be employed to identify multicollinearity, including correlation matrix, variance inflation factor, and condition coincides. Detecting multicollinearity in R. So, how to detect multicollinearity in R? So, this is a basic process. Correlation matrix. The core function, COR function in R, calculates the correlation matrix, revealing the strength of linear relationship between two variables. So basically, the core function calculates the multicollinearity in the data shifts or data set from the variables. So to calculate the collinearity, the correlation matrix of between two variables, we use the core function, variance inflation factor VIF. The VIF function from the car package provides VIF value indicating how much the variance of coefficient is inflated due to multicollinearity. So how much the coefficient is inflated due to multicollinearity, the VIF is introduced. Detecting multicollinearity in Python. How to detect multicollinearity in Python? We have discussed that to find out the multicollinearity in Python in R, we use the core function and we use the VIF function. Now in Python we use to find the correlation matrix, we use CORR function, which is in Panda libraries, to calculate the correlation matrix, highlighting the pair of variables with the high correlation. Variation inflation Variance inflation factor, sorry. The variance inflation factor function is also there for the status model for providing VIF values, helping to identify variable with high multicollinearity. So these are there are two functions which are basically used to find out the multicollinearity in Python. The first function to define the composite correlation matrix is core function, and the second to determine the inflation vector, the variance inflation factor method. Understanding principal component analysis. What is PCA? PCA is basically divided into three key terms: data transformation, dimensionality reduction, feature extraction. So, PCA transforms a set of correlated variables into a smaller set of correlated variables called principal components. So, basically, data transformation breakdowns the correlated variables, which is the very big data, into more small sets variables, so that it can set of uncorrelated variables That is called basically principal component. Dimensionality reduction. The principal component capture the maximum variance of the original data, effectively reducing the dimensionality without significant information loss. It effectively reduces the dimensionality without any data loss, information loss, or anything. Feature extraction. PCA can extract meaningful features from high dimensional data, facilitating visualization, model building, and data analysis. So basically, PCA can extract meaningful features and from high level dimensional data, facilitating visualization, model building, and data analysis. So basically, PCA is divided into three key components: data transformation, dimensionality reduction, and feature extraction. These are very important key terms to learn to memorize. You need to understand these very carefully. Implementing PCA in R. The PR com function is in a R performs PCA calculating principal components and their corresponding engine values and engine vectors. So basically, the PRCOM function performs the PCA in R. Engine values. Engine values represent the variance explained by the principal components. So engine values basically represents the variance that is done. This is given by the principal component, indicating the importance of each component. Engine vectors. Engine vectors represent the direction of each principal component of the original variable space, showing the linear combination of variables defining each component. Interpreting PCA results in R. Screen plot, cumulative variance, component loading. These are the basically three things that we need to understand about interpreting the results in R. Screen plot. What is a screen plot? A screen plot visually displays the in values of each principal component, showing the variance explained by each component. What is cumulative variance? The cumulative variance explained by the selected principal component indicates the percentage of total variance captured by the reduced dimension. Component loading represents the correlation between the original variable and the principal component, providing insights into the meaning and contribution of each variable to reduce dimensions. Implementing PCA in Python. How to implement PCA in Python? sklearn.decomposition.pca. The PCA class in sklearn provides an effective implementation of PCA, allowing to easily to calculate the principal component and analyze the result. Explain variance ratio. The explain variance ratio attribute provides the proportion of variance explained by the each principal component, helping to identify the most information component. Component loading. The component attribute contains the loading, showing the linear combination of original variables defining each principal component. Interpreting PCA results in Python. Scatterplot, component loading bar chart. Visualize the transform data pointed to reduce space helps to understand the underlying patterns and relationships within the data. A bar chart illustrating the loadings of each original variable on the principal component, revealing the significant variable contributing to the reduced dimension. Applying PCA for dimension reduction. Model building, data visualization, and feature extraction. Model building, data visualization, and feature extraction are very important topics you need to learn about in data science. They will come in every video of our PCA will help to reduce the complexity of model by reducing the number of input variables, improving training time, and potentially boosting accuracy. Data visualization. By reducing the dimensionality, we can more efficiently visualize and analyze the data, leading to the better insights and understanding of patterns. Feature extraction. PCA can be used for extract meaning features from complex datasets, providing me more efficient, concise representation of the data that can be used for downstream analysis. So this is for today's video. If I hope you liked the video, you understood the concept of basically the dimension reduction. If you like the video, please give it a thumbs up. If you have any doubt, check the comment section and put the doubt in the comment section. Please subscribe my channel. Till then, stay tuned. Thank you.